Okay, hello everyone, and good evening, and thanks for joining. Everything fails all the time. It was nicely quoted by our Amazon CTO, that is Werner Vogel. So we all have seen Tony Stark's Iron Man suit. Right? That's Jarvis. So it's basically a system that detects the issues. It itself fixes that issues and learn from their experiences, right? In the fly. So, however, in the cloud operations, humans are still acting like a robot because they are still following the run books, playbooks, they are copy pasting their commands and running in the CLI. So, I started asking what if that infrastructure fixes itself like that Iron Man suit. So, yeah, that's the topic we are going to talk about today. So let me quickly introduce myself. My name is Dr. Rahul Gaikwad. I'm joining from Pune, often called as the Oxford of the East. I work as a solutions architect at HashiCorp, an IBM company. And yes, you heard correctly. I'm doctor. I don't fix the broken bones, but I can fix the broken infrastructure. So let's quickly deep dive into the scenario. So please raise your hand if you have been in the situation where you got pulled in the midnight for production outage. How many of you? Perfect, almost all. So yeah, the same situation happened with me a couple of times when I was working as a DevOps engineer, and then I realized the impact from the business perspective. There is a research conducted by Gartner. As per that research, it cost around $5,600 per minute when you're sleeping during the during the production outage. So let's talk about those common issues, common failures in the production. I have seen, based on my experiences, I just shortlisted 3 scenarios for this today's talk. EC2 failures, it can be any issues like your EC2 get stopped or terminated, or during the production outage, someone may fix the security group from the console. So imagine that you have provisioned your infrastructure using the infrastructure as a code using the Terraform. And during the production outage, like everyone wanted to fix that issue. No one going to update the Terraform code and then go through the PR process and all. They generally do go into the console and update the security group or whatever they wanted to make the changes, and then they fix that issue. But what happens if you fix that issues, that will create a drift in your Terraform state file. So how can we fix these issues automatically? So if you look at the numbers, generally for EC2 failures, it takes like 15 minutes. And if there are any production outage, it takes around 45 minutes. That is a kind of a MTTR to fix the end-to-end issue. So if you talk about the numbers, the impact, business impact, it comes around 252K per incident. That is the numbers that is as per the Gartner. It's not my number. So imagine how much that common failures causes the business impact. So let's understand this timeline. This is a standard typical timeline. When alert triggers, engineers wake up, he started log investigation, and then he write the fixes, maybe a Terraform or maybe any ISC solution, and then it deploys the solution in the production. It takes almost 45 minutes. So we already have a lot of tools. Maybe it can be a CloudWatch, it can be a CloudTrail or Splunk or any observability tools. And for ISC, it can be a Terraform or Pulumi. But all these tools are there, but they are not talking to each other. That is the gap. And in this talk, I am going to fix that gap with our custom agent. So the question is, what if the infrastructure fixes itself? No runbooks, no pager, no 3M calls. How can do that? So let's see in the action. So this is the code repository, and you can see I will share this code samples as well. So the important piece is you can see all this Terraform code is written with the best practices. All the Terraform modules are there, and you can see all the resources is already defined for these scenarios. Like we are targeting 3 scenarios: EC2, security group, and IAM. You can see I have written the code for agent code, Bedrock, Strands agent using the Lambda layer. And don't worry about the code. I will share the code samples. Yeah. And you can see I use the variables so that you can implement it into multiple environments. So let's see how we have deployed the resources into the AWS console. So we have this agent core memory. I use two types of memory here. You can see the one is semantic and the other one is summarization for RCA and recommendation. And then you can see I have deployed the Lambda function, that is a supervisor agent, and it's using the strand agents as a Lambda layer. You can see here, I have shown here in the layer, we are using the strands agent. And then I will show you the Terraform code. So this is the logs that we will be monitoring for our solution. Based on that, it will trigger the SCP Terraform pipeline. You can see here, this is SCP Terraform, and you can see there are multiple runs. Based on your changes, it will automatically trigger your pipeline. Now you can see first challenge. So we are targeting 3 issues. The first is if someone intentionally created a security group which is open for all the world, how we can fix that. It's again a self-healing. Based on your updates, it will automatically trigger the alert and it will send you the Slack message for the approval. It's not automatically doing all the actions. So if you remember the yesterday's session where David talked about the DevOps agent, but it's just providing the recommendation. It's not taking any action. But in this custom AI agent, you can see it's automatically taking the action, and still we are using the human in the loop. It's sending the PR request in the Slack message. As a human, I will review that. Once I approve it, it will automatically go into the SCP Terraform. It will create the job. It will write the Terraform code for that specific resources to revert that change. Once I approved, I want to revert that security group change that someone has made from the console. So I want to fix that RIP. So you can see that agent has already went it and it revoked that security group specifically. So that is the first use case. The second use case is suppose you have already an important security group like 443 port that is very required, and someone may delete it from the console by accident. So how can we revert it back? In this demo, you can see I deleted it. It will again trigger the Slack approval message. Once I approve it, it will go back. It will fetch that from the agent core memory, and then it will create that resource again. So it's basically self-healing. There is no action required from my side. Only the approval and denial part is as a human, I will do that. The next is the security group itself. If someone deleted it, very important from the database perspective. If someone deleted, there will be a chances of power outage. So in this case, someone deleted the security group. Again, it will fetch your Terraform state file and your agent core memory. It will identify which resource got deleted. So it will go and it will recreate that. So there will be very minimal downtime. Imagine if it is a human who will do that part, it will be almost 45 minutes. So the next use case is a EC2 scenario. If someone had some issue with EC2, if it got stopped, and it is very critical from the business perspective. So it will, if it is stopped, it will automatically recreate that EC2 instance with the same AMI. So there will be a very less outage from the business perspective. That is another use case from the second scenario. The third one is during the cleanup activity, if someone may delete some important IAM role, it may impact a lot of EC2 instances or users as well. So in this case, it will identify what was the IAM role, what was the policy was attached, and it will revert back. So that's how, this is just a prototype to showcase how we can fix these common failure issues with the custom AI agent, which is not available in current DevOps agent capability. So with this custom agent, we can have all these capabilities. So what is the outcome? Oh, okay. So before that, I would like to talk about the architecture, because we have seen already the magic, but this is the very high level. You can see we have 3 layers: detection layer, strands agents, and the remediation layer. So what is the outcome from business perspective? As we talked earlier about MTTR, it's almost 45 minutes. But with this solution, it will be less than 10 seconds. Again, you can measure it in the seconds only. So what are some takeaways? I want to take 3 takeaways from this session. The first is obviously AI agents can do a RCA recommendation and actions more accurately and quicker, faster than any human. The second is we should always use any kind of ISC. In this case, we use the SCP Terraform. I will highly recommend for any kind of infrastructure automation. And the third is a human should be there as a in the loop as an approver. So this is the code sample. I can share that later as well. And these are the last highlighted slide that currently this part is not available in the DevOps agent. I tried to fix to created with this innovative solution where we try to minimize those gaps from the DevOps agent. Yeah, we are on time. Yeah, thank you.